Alright, this is Mr. Gillum, and today we're going to start learning about area of shapes. Area is the amount of space inside a figure or shape. And so when I refer to area on like a square, I'm talking about how much space is inside here. Okay? You may know the word perimeter, which is how far it is around the shape. That would be referring to the perimeter. But we're going to talk about area today, which is the part inside the shape. Okay, so first of all, we'll start with the square. And to identify a square, there's a few things you need to know. A square has 4 sides, and each of those sides has the same measurement, meaning they're the same length on each side. And I think we talked about yesterday in the video that if this length is the same as this length, we put a dash on either one of them. And if this length is the same as those other 2 lengths, we put 1 dash on each of those. And so that indicates that they're each the same length. Also, if you're talking about a square, you need to know that there are 4 right angles. So to indicate that it's a right angle, we put a little square on the side there, because a square is a right angle. Okay, and so it has 4 right angles, 4 equal sides, and is 4-sided. And so to illustrate area, what I'm going to do is I'm going to use this coordinate plane. Now, we're familiar with this. We've used this before, and I'm not so concerned about the axes now, but what I am concerned with is how much space is on the inside. And so I'm going to just draw a square here. I'm going to draw a few different sizes of squares. So let's start in quadrant 1. I'm going to just say that I have a square, so 2, 2, 2, 2. Okay, so this is a length of 2, 1, 2, and a length of 2, 1, 2. Length of 2, length of 2. So I know I have a square. These are all right angles. And so how much space is inside? Well, I can count. 1, 2, 3, 4. There's an area of 4. So a square with a length of 2 on each side will have an area of 4. Okay, now let's make our square a little bigger in the next quadrant. We'll do 3 by 3 3 by 3. Okay, so this is a length of 3, 1, 2, 3. This is a length of 3, 1, 2, 3. This is a length of 3. This is a length of 3. And so I know I have a square. Let's see how much area or how much space inside there is. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so if I had a square that was 3 on each side, and they were all right angles, of course, then I would know that it has an area of 9. Interesting. I'm starting to see a pattern develop here. Let's try the third quadrant here. We'll do 4 by 4. Okay, so that's 4 long, 4 long, 4 long, and 4 long. And I, of course, know that these are all right angles in here. Let's count and see how much area there is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 14, 15, 16. There's a total area of 16. And so if I had a 4 by 4 square, I would have 16 on the inside. Let's try one more here. What if I had a 5 by 5? 2, 3, 4, 5. 5, 5, 5. If that's 5 long and 5 long and 5 long on every side, and although of course there are all right angles, how much space would I have inside? Well, instead of trying to figure this out by counting up, because the squares are getting to be a lot, let's see if I can find a pattern. If the lengths are 2, the area is 4. If the lengths are 3, the area is 9. And if the lengths are 4, the area is 16. I don't know if you're seeing a pattern yet, but the pattern that I see is that if I multiply the length times the width, then I'll get the area. And so when I take 2 times 2, I get 4. When I take 3 times 3, I get 9. And when I take 4 times 4, I get 16. Let's see if that happens with 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. How about that? A square that would be 5 by 5 would have an area of 25. Now, I did not label anything on this page, but I am going to make the point here. The area of a square can always be found by the length times the width. Okay? And let's make ourselves a little note here somewhere. area is measured in what we call square units. And I bet you can guess why we call it square units, because each of these units in here is the shape of a square. And so when we talk about square units, we're talking about area. Okay, and so really we should say a 2 by 2 square would have an area of 4 units, and we're, instead of saying square units, we're going to say units squared. And a square with 5 by 5 would be 25 square units, but we would abbreviate that in math as square units with a little 2 above it. That's the squared word. It means squared. Or 16 units squared, we would call that square units, or 9 square units. Okay, and so when we label our answer, we need to label it in square units because that represents area. And a good way to remember that is you can see that the area is divided into squares. Okay, so importantly though, we found the pattern that the area of a square is length times width. Now let's talk about a rectangle. It's very similar to a square, except for there's one big difference. Not each of the sides is the same length. And so again, with the rectangle, we're trying to figure out the area of it. We want to know how much space is inside. And to do that, we want to see how many square units will fit in there. Square, 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 square. And so a rectangle also, though, does have 4 right angles. The big difference between a square and a rectangle is that the rectangle doesn't always have to have the same side lengths. And so let's do a little experiment with the rectangle. We're going to get a little crazy with the rectangle here. We're going to start with like maybe a 2 by 3 rectangle. 3 and 2. And I see that the number of square units inside is 6. Okay, not so bad. Let's do a different rectangle. Let's make it a little skinnier and taller. 1, and we got 2 by 1, 2, 3, 4, 5. 2 by 5. This length is 1, 2, 3, 4, 5 long, and this is 2 long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well that would be an area of 10 square units. We would say units with a little 2 above it. Okay, 10 square units is how we'd read that. All right, interesting. And if I had a rectangle, there's a little maybe a chubbier rectangle here. We got 1, 2, 3, 4, a length of 4 there, and a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 6 there. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. An area of 24. Well, let's just figure out here. If I had a real skinny one, we'll change color again. If I had a real skinny one just like that, and a length of 1 on the side, and a length of 1, 2, 3, 4, 5, 6 on the top, I see 1, 2, 3, 4, 5, 6, 6 units of area, 6 square units. So what I would say is that I'm developing another pattern. I'm going to predict that if I had a big rectangle here, that was 1, 2, 3, 4 on the width, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on the length. I'm going to predict that there are 44 square units in there. And I know this because I'm following a pattern. 2 times 5 is 10. 2 times 3 is 6. 6 times 4 is 24 square units, and 6 times 1 is 6. And so I'm just going to follow the pattern because after all it would take me a long time to count all the way up to 44. And so the pattern that we're learning is that the area of a rectangle is also the length times the width. And the length and width are just names of sides of the rectangle. Okay, length times width. So now we know how to define the area of a square or a rectangle without having to shade in all of the units. And finally, we have triangles. And a triangle is a little different than the rectangles. But one thing about a triangle is that it's exactly half of a rectangle. And so it's hard to see on this first diagram, but if you see this second diagram, if I reflected this point up here, I would have two equivalent triangles. Look, any rectangle, if you break it right into two parts, we'll have two triangles. Both those triangles are going to match. And it's a little harder to see on this one, but if I had the same, if I just went and I could make this one rotate around to be right there, and I'd have the same triangle again. Didn't draw that triangle very well. I have the same amount. And so there's a relationship here. So this amount would be the same as this amount. Okay? And so there's a relationship between triangles and rectangles that I'd like to try to discover here. But I will tell you that right off the bat that a triangle is exactly half of a rectangle. And so we're going to start with what we call some right triangles. We learned a little bit about those. Let's just do a right triangle here in the first quadrant. I know that's a right triangle. There's my right angle, and it's a 2 by 2. Now this is going to be a little harder to count up the number of squares in here because it looks like some of my squares are cut in half. So really I have 1.5, 2. This has an area of 2 square units. All right, let's do a little bigger triangle this time. Ooh, this is hard. Okay, we got 1, 2, 3, 4 by 1, 2, 3. Okay, and it looks to me like I have 1, 2, 3. Uh-oh, this is going to be a hard one to do because it looks to me like these don't really match very well. If we had to estimate, though, if I had to count, see, the part of the problem is that I can't tell how much of a square that is there. Man, that's going to be difficult. Maybe I should choose a different example in that one. Let's just do a 3 by 3 this time. And you can see that I have exact halves now. So there's 1, 2, 3. This is 3 and this is 3. And then 3.5, 4, 4.5. So that has an area of 4 1/2 square units. Okay. Let's try a 4 by 4. 1, 2, 3, 4. Oops, too far. We'll do 5 by 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this time I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10.5, 11. 11.5, 12. 12.5. And let's just try one more here. Do this big old 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 full ones, then 15.5, 16, 16.5, 17, 17.5, 18. So we have 18 square units on a 6 by 6. And so going back to the relationship I talked about just a second ago, I know that if I made another exact triangle the same way, I would have a square. There's a square. There's a square. There's a square. And so I'm starting to see a pattern here. Let's see if I can make my numbers work the same way. I see that each of these triangles is exactly half of the area of a square. So let's see here. I see that 2 times 2 is 4, which is twice as much as 2. I see 3 times 3 is 9, which is twice as much as 4.5. I see 5 times 5 is 25, which is twice as much as 12.5. And I see 6 times 6 is 36, which is twice as much as 18. And so I'm starting to develop a little pattern here that I think if I multiply the length times the width on, or what we call as the base times the height on a triangle, I can figure out the area if I just divide it by 2. And so that's what I'm going to say on my triangle here. I'm going to say that length times width divided by 2. Or you could say base times height. Sometimes they say base times height divided by 2. Now this even works for triangles that aren't right triangles. So in this case, like the triangle I tried to draw earlier, let's draw one like this. Um,